Right, in today's video, we're going to be talking about differentiation. Differentiation is the process of finding the derivative of a function. The derivative of y with respect to x is mostly written as dy dx. Dy dx is called the Leibniz notation. The derivative of f of x with respect to x is written as f prime of x or dy dx of f of x. We do have higher derivatives as well. So the first derivative is denoted as dy dx, that is according to the Leibniz notation, or f prime of x. The second derivative is denoted as d square y of the x square or f prime of x. Now we are writing the second derivative as d square y over d x squared, because the d square y x squared could be written as d dx of dy dx. So this is what we need to note, right? So with this, then we can also talk of how the third derivative could be denoted. The third derivative could be denoted as so from what we have here, then the third is going to be d of dx, d dx of what? The second, which is what? D square y, then dxy square, and this is going to give us d 3y dx cubed, right? So from this we can also have the fourth derivative. Now the third derivative, it could be written as this, or probably like this, f. So the second one, let's look at the first derivative. The first derivative, when we are having the function f of x with respect to x, the first derivative is having one prime, right? The second derivative, we had two primes, so the third derivative is going to be how many? 3, right? So 1, 2, 3, then we have our what? X, meaning the function is of what? Or the function is with respect to what? X. The fourth derivative fourth derivative is going to be denoted as what? D of dx of the third, which is d raised to the power 3y, then ds cubed. And this is going to give us what? D of exponent 4, then y, then x raised to the power 4. Or probably, if the function is of f, then we're going to have f primes. How many primes? Since we're talking of fourth derivatives, we're going to have what? 4 primes. So 1, 2, 3, 4 of what? X. Right? Cool. Now from here, I think we can write the nth what? Derivative. Okay. So let's look at something. Is denoted as, look at something. The first derivative, we were having the d to be having an exponent of 1, right? Then the exponent of the x is 1. The second derivative, we have the d having an exponent of 2, and the x is having an exponent of what? 2. Okay. The third derivative, we are having the d, third derivative, d is having an exponent of what? 3, and then this x is having an exponent of what? 3 as well. The fourth derivative, our d is having an exponent of 4, and then the x is having an exponent of what? 4. Then from this, we can deduce that the nth derivative is going to have, or is going to be, d raised to the power n of y all over d x raised to the power n, or probably f of what? N, then x. But note, if you're writing it as a function, then your n, they're going to be primes, right? So you're not going to write, probably if you're talking of the fifth derivative, you're not going to write 5 here. You're going to write 5 what? Primes. Okay, so with this, easily, if I want to talk of the fifth derivative, just going to be fifth derivative is going to be written as d raised to the power 5 of y, then dx raised to the power 5. Or probably, if I want it to be, if it's a function of f with respect to x, then it's going to be how many primes? 1, 2, 3, 4, 5. Okay, yeah, 5 primes. Yeah, 1, 2. Okay, let me write it well for better view. So it's going to be the primes 5. 1, 2, 3, 4, 5. Then I have my x. Okay, yeah. Now, having taken note of these, the next thing I want you to note is that the first derivative in simple terms, it means this change or the gradient of the function, right? The first derivative, it could mean the change or the gradient of a function. So with this, let us look at some rules of finding the first